Hello guys, in this video I'm going to show you how to solve scheduling task problem. So you're given a list of tasks that need to be run in any order on a server. Each task will take one CPU interval to execute, but when a task is finished, when a task has finished, it has a cooling period during which it can't be run again. Alright. If the cooling period for all tasks is k intervals, find the minimum number of CPUs intervals that server needs to finish all tasks. Okay, a lot of information, but let's take a look at an example here. Uh, Alright, we are given a list of tasks, right? It's represented by alphabet characters. So here AAA is actually it same task, right? Name A, and here we have only one task B, and here we have task C, two task C, right? So I'll put it 7. Why is that? So essentially here we're trying to we need to execute a task, right? In a way, in an order that we have cooling period between two same tasks, right? For example, A here, we can't have two tasks A next to each other, but there must be two two cooling period in between, right? So during the cooling period, we could put other tasks in so that we can optimize for the minimum number of CPU intervals, right? So the constraint here is that we can't have we must have two same tasks. Two same tasks must be let's say in this case k plus 1 away from each other, right? So in between two tasks A, we have two cooling period, right? So okay, same for task C. We have two tasks C. So the cooling period between task C must be we must be two cooling period between two tasks C, right? But here, as you can see, interesting thing here is that for these two tasks A, there's there are two cooling period, which is one is task C and one is idle. Why is that? Because we are out of task here, right? So let's do it gradually so you can see why we do that. So because I have, let's say I have Okay, let's go to the okay, let's delete this kind of stuff. Okay, here it is 3A, 1B, and 2C, right? So because A has the most frequency here, so probably I will prioritize task A, right? So I will try to push task A first. So I will put in a way that between two tasks I have two cooling period. Right? So I. So between must be something. Right? Next, I will put task C because it has a second largest frequency here. So I will put on the next empty slot here. Okay, I will put C here, and the other C must be 2 away from this C, so it must be here. So I have only one B left, so just put B here, and we have this empty slot because A must be 2 away from each other. So for this one, I'm gonna leave it empty. Just it is idle here, right? So how I wanna solve this problem? As you see here, uh, we try to optimize the um, we try to prioritize the tasks with high frequency, right? So this leads us to this observation leads us to a data structure that um, optimized for this kind of operations, which is extract the item with largest frequency, let's say. So this is good for a mux heap, right? So okay, as you see, as you the idea here is gonna try to allocate the the item with the high frequency first, right? So let's do it one by one so that you can. Okay, the first thing, because we prioritize this A because it has a high frequency, so probably I take it out, right? Okay, I take it out and I will allocate one A. So it means the A from 3 will down to 2, right? What is the next step? Should I bring this one back to the mux heap? Probably not. If we bring it back to the mux heap, A could potentially become item with largest frequency again. So we must wait until we have at least uh, two different tasks that is put right after A, so that we make sure that we have cooling period between two tasks A. Two cooling period between tasks A, right? So I need to wait for a certain amount of time. So for this observation leads us to another data structures, which is a queue, right? So after updated here, I can bring it. Oops. I will push it in the queue, and I will just keep processing here, and then we could just add it to the queue. Let's say, okay, let's say, what is the next one that come out from the Maxi? It is C2, the next largest frequency. So, okay, I would like to put one C here. So it means the C here will come down to 1. After that, I will push it in the queue, right? Next, next would be B1, that is now, and for B, I will put 1B to my current task order, right? So after that, I will update B here down to 0. Okay, and then I'm gonna add it to my queue. So as you can see, at the time that the queue size is 3, which is k plus 1, we have 2 different tasks that come after A, right? So it means that at this point, it is possible for me to put another A here, right? So that we can satisfy the constraints, right? So at the time that number of items in the queue is k plus 1, then I can bring the first item back to the max heap, right? Oops. So let's see. Okay, so now our max heap has 1 element. We can take out it once again. So A2 will come out again. Right. So next would be take 1A from take 1A to our current task order. So it means the number of A here must be down to 1. Okay. And then I'm gonna put it back to the queue. Right. and so on and so forth. This will totally work for our problem, but you might notice that we are doing some unnecessary work here, which is uh, the problem here requires to only find the minimum number of CPU intervals, right? Which essentially the length of this task order at the end, which is in the case 7, right? But we don't need to find this task order. So because of that, when I try to uh, optimize our algorithm a little bit, because we're not gonna need these um, task order anymore. But let's try. Let me undo everything here. Okay, so now so essentially here when I think we're just gonna keep a count of how many um, tasks that we have processed at the current time. Let's say in order to optimize this problem, probably one way to do is wanna process the items in the marks heap in batch instead, right? So because I want choose tasks that are the same must be um, two away from each other, right? Let's say. So it means that let's say at it at every step I'm gonna try to uh, take out from the max heap k plus 1 items, right? Let's try to do it here. So uh, the first the first batch would be A3, B1, and C. And here, um, it, let's say, because how do I put this? Okay, we take out 3 items, but it could be the case that we don't have enough items to uh, we don't have as much as k plus 1 item. There are cases, right? But let's handle these first. So we take out 3 items from the max heaps. So it means that these are three different items, right? These are three different items. It means um, I could put these in my at the first batch in my order list, my task order, and then after that I could and it's guaranteed that in each batch there's no task that is the same. So it means that uh, I could let's say I'm gonna keep a task count. So in this case I take out k plus 1 items, so the number task count currently is 3, right? And for these uh, tasks, while taking out, I also need to um, let's say I need to update it before adding it to the queue. Let's say um, B here, B, B without 0, but because the B here is down to 0, do I really want to put it in the queue? Probably not in this case. But for C2, so let's I think this could go out, don't care about it. But C2, let's say I'm gonna update it down to 1 frequency. Simply mean we still have C character to execute, right? 1 task C to execute. So I will push it in the queue, right? So after that, I will add everything back to I will add item back to the mux heap, right? Okay, we're done with one batch, right? So for the first batch, we executed 3 different tasks, right? Okay, on the next batch, let's see. On the next batch, I will take out, right? And also I need to update the frequency of A down to 1, and frequency of C will go down to 0. So as you can see, in this case we use 1A. In this batch we use 1A and 1C, right? Actually it, here it this A and this C, even we use only one A and one C in this batch, but the task count in this time still be +3. Why is that? Because as you can see, after I update the frequency of A and C, we still have one A, right? So it means that even though we couldn't fill all the tasks in this batch, so each batch will process 3, let's say this 3 and this 3. Here's the first batch and here's the second batch. And this batch will process only A and C, and we still have an empty we must leave one empty slot here because we still have one A, right? That last A will come on the next batch, so we cannot end right here. So we still add 3 here, which is include AC in one empty slot. Okay, I try my best to explain this kind of thing. It's very difficult. Okay. Okay, because C down to 0, so it means I'm done with C. Oops. So I will pull out of my view. Okay, so we have step 1A. Wanna put A back to the max heap. Okay. Okay, on the next batch, wanna try to pull out again 3 items, which is K+1 here. But at this time, we cannot pull out that much. We cannot pull out only one item because that's everything that is in the max heap right now. But that's fine. But this time I'm gonna update it here because the frequency of A will go from 1 to 0, right? So it means that after using item A from this batch, we have nothing to put back to the max heap anymore, right? So it means that we don't have the next batch, and the task count at this batch will not only +1, right? So the idea here is that if we expect that we have the next batch will +3, which is K+1 to the task count, current task count, but on the batch after process one batch, there's nothing coming back as max heaps. Also means we don't have the next batch. And then it means that the task count will be updated with only the items that I've used, only the things that I have used in this batch, which is A. So it will be +1. Okay. So A down to 0, it also means that I'm done here. I will take it out my view, and also we're done with our implementations here. Okay, let's try to turn everything that I've written here into code. Okay, so there's a couple of things we need to do here, which is first, I need to count frequency of each task, right? Then I'm gonna add task and task frequency into the max heap, right? To optimize the operation to take out the task with the high frequency. Next, we're gonna process in batch of k plus 1. Want to answer the questions, do we have next batch? If yes, then want to keep a task count. If yes, the task count will be plus 3. If no, task counts will be plus 1. Okay. Sorry, it's not plus 1, but number of tasks used in this batch. Okay, and at the end I'm return what task counts. Okay, let's do it one by one. First, frequency of each task. So it's simply a map, right? Where key is a characters and value is a frequency. So I'm gonna loop through every task. So for each task, I'm gonna check if the task is not in the frequency, then I'm gonna initialize task frequency to 0, and right after that, I'm gonna update the frequency of task by 1. Okay. So next is to feed it to the max heap. So first to create a max heaps heap. Okay, because it's a max heap, so the third argument here will determine that. So ABA is actually this. We decide the data structures of item in the max heap, which is just an array. The first element is a task, and the second is a task frequency. So in order to instruct heap how to extract the task with the largest task frequency, I need to compare the task frequency of A and task frequency of B. Okay. And after that, I'm gonna feed the maxi with all the items in the frequency. So loop through the map frequency. Okay. So for each task, I'm gonna add to the max heaps. Here with task, and the second will be the frequency of the task. Oh, I need a task count. Initially is 0, and finally I return the task counts. I'm gonna process in batch. I'm gonna process in batch of k plus 1, but so we're gonna do something like but this will be inside another loop, which is keep the process as long as we still have something in the mux heap, right? So inside, when I process a batch of k plus 1, let's call it task, number of tasks. This batch is k plus 1. So when I keep pulling out from the mux heap as long as the number of tasks is greater than 0. So with these conditions, we want to process k plus 1. We want to take out at max k plus 1 item from the mux heap. And every time I will decrement this by 1. So it basically goes from k plus 1 to 1, right? So it k plus 1 items at max. But it could be the case that we don't have enough items in the mux heap. So here we must have another condition, which is the mux heap length is still greater than 0. Okay, we still have something in the mux heap. So here inside I will take out from the mux heap. I'm gonna pop out. Here will be task. I'm gonna destructure it into task and task frequency, right? So I want to count how many items that is used in this batch. Let's define another variable. So before we jump into here, we want to initialize it with 0, right? Because it could be the case that we only process a fraction of k plus 1 for this batch because we don't have enough items in the mux heap. So this will keep track how many items, how many tasks that we use in this batch. So let's say at each time I will number of tasks used in this batch will be plus 1. Okay, but how was this? I think we need to store it in a we need to store it somehow, right? And we must store it in a queue, let's say, so that after process one batch, we could at the end we could bring it back to the maxi, of course, if we still have items to process. So if I keep a queue here properly, we don't need this one, because this will be the size of the queue at the end. So just remove it. Okay, so I'm gonna push task and task frequency, but is decremented by 1 because as we pop this item out of the maxi, it means we decided to process it, to put it in our task order, even though we do not do it explicitly here. Okay, but we only not do this one if after updated it's still return 0. Right? Because this letter will be added back to the maxi. Okay, so next wanna answer, wanna exit this when we're done, when either we process everything in here or we have out of items in the maxi. So do we have next batch? We decide this question, we decide how many items we gonna add to the task care, right? But do we have next batch? What does it mean? It means it's equivalent to how many items do I have in the queue right now. If I have the more than if I have at least more than one items in the queue, it means I still have something to process in the next batch, right? So it means that the task count will be plus k plus 1, k plus 1. Okay. If if what is that? If the queue size is still equal to 0, else is equivalent to yes, we still have the next batch. It means that I can fill as much as k plus 1 in this batch. So task count will be added by k plus 1. Okay. Else we're just gonna number else. In this case, we only update task count with the number of tasks that used in this batch, and this is actually can be calculated by let's say here's the number of tasks you in this batch, maximum, right, to process, and at every time I process one item, I update decrement this by one. So actually here is the same number of tasks in this batch, right? So here would be number of tasks in this batch. One thing that we forgot here, which is we must bring back the item in the queue to the max heap, right? If we still have any, so it should be in this block when we do have something in the queue. So let's say queue just an array. So for each item in the queue, I don't care about the order here. So item, I'm gonna add it back to the max heap. Item. Okay. Let's run the test. Oops, we have failing test. We have undefined. I think max heap is undefined. Not sure what went wrong here. I know why. We have one heap here. New heap. Not sure. Let's debug it a little bit here. Okay, how good it here. Task in frequency. Task in frequency. Task. Okay. I think good here. As long as not. Okay. I know what. Here it should be an array instead. Still not working. Must be something wrong. Okay, let's run it once again. I know why. Uh, here, here's the number of tasks maximum, right? In this batch, it is different from number of tasks u in this batch, right? So this will count down from k plus 1 to 0. So the number of tasks uh, that is used in this batch must be k plus 1 minus current number of tasks in this batch instead. Okay, that works. So that is it for this program. It's very difficult to explain, but finally we made it. So thanks for watching. See you in the next video.